Okay, so this is the second part of 5.5. We're going to still do the same thing. We're going to take this function, we're going to write it in vertex form, name the vertex, and then solve. This one is different because there's something multiplied to x squared. So you can't do the normal procedure where you would just take the constant, move it to the other side, and then do plus blank, okay? We're still going to take the constant and move it to the other side first, okay? We can start doing that as long as it's y equals. You don't want something else mixed with the y, okay? We want y equals. And even though the y is on the other side, that's fine. If they're equal, they're equal, okay? So we can leave it over there. But if you're not comfortable with the y being on the right-hand side, you can reverse the two sides and it's fine. But I'm going to leave it like that. So step one is take your constant and put it on the other side with y. So now we have 2x squared minus 12x equals y what? Minus 16. Now, the rule is you can't start completing the square until the coefficient of x squared is a positive 1. So what are our options? Okay. So you're going to automatically think divide by 2, which is not a bad direction to go in. If I divide this by 2, I'll just have x squared, right? But when you multiply or divide in the equation, you have to do every single term by that. So if I divide this by 2, that's still not a problem. That gives me 6x, right? If I divide 16 by 2, I get 8. You can't skip a term. So that means I have to divide y by 2 also. Well, now I have y divided by 2, or 1/2 times y. Okay? So dividing by 2 is not the best route to go. What's another method? What can we do? What else can we do? Can anybody think of anything else we can do to get rid of this 2 so that we just have x squared? No? No? We're going to factor out 2 from the left-hand side. When you factor out something, you don't have to do it to both sides. You just do it to one side. So, I'm going to factor out a 2, which means I am dividing both of those terms by 2. Okay? And the 2 goes on the outside of the parentheses. So, what am I left with inside the parentheses? X squared minus 6x. Do not make the mistake of only dividing the first term by 2. When you factor something out, you have to divide every term by that thing that you factored out. Because, as Mama's noticed, I could make you put it all back together. I could say, okay, put it back together. Which means you would have to redistribute the 2 and get back to the step where you were before. Every step has to be equivalent to the step below it and above it. Okay? Equals y minus 16. Okay, good. That got my x squared by itself. So now, looking at this, remember, our goal is to put this in vertex form. Here's vertex form. What do you think that 2 represents in the vertex form? A. Very good. When we're done, that 2 is going to be our A. On the problems you did last night, A was just 1. Okay? So, now what we need to do, it'll end up being A times a binomial squared. So we have to take this and turn it into a binomial squared. Alright? So we're going to do that, and the only way to do that is by completing the square. So from here, we're going to start doing what we used to do. Plus blank, plus blank. But the first plus blank on the left is just going to be inside the parentheses. Okay? So we have 2 times x squared minus 6x plus blank equals, if you add something to the left, you also have to add an equivalent amount to the right. Okay? Now we have to force this to be perfect. Okay? So we take our middle term, divided by 2. We're dividing it by 2 because that's the rule. You always divide it by 2 and then square it. Me dividing it by 2 has nothing to do with this 2 on the outside. Okay? Because the next problem, we're going to factor out 3. And you're going to think, oh, you're going to want to take that and divide it by 3. No, no, no. When you find that C that makes it a perfect square trinomial, take your middle term, divide it by 2 and square it. So 6 divided by 2 is 3 squared is 9. Okay, so this is where this is a little bit different. Okay, we added 9 to that side. We added 9 inside those parentheses. In order for this to stay equal, in order for the left side to stay equal to the right side, we have to add an equivalent value to the right-hand side. How many did I actually add to the left-hand side? 18. Why? It's 9 here, but there's a 2 outside of here that's saying multiply it times that, right? This 2 gets multiplied to everything in that parenthesis, right? So I actually added a total of 18 to the left. So I have to add 18 to the right. When you complete the square inside of parentheses, you're not going to be adding the same number to both sides because you factored something out in the beginning. So once you figure out what goes here, you have to multiply it times what's outside the parentheses to figure out what goes on the other side. Okay? Now from here on out, we're going to do it the same. We're just going to carry the 2 that we factored out down to every step. Okay? So now this is our perfect square trinomial. Now we can write it like our binomial square. Okay? So we have 2 times. What goes in here? X plus or minus? Minus what? 3. And that equals, now you have negative 16 plus 18 is positive 2. Okay? We're almost done. Is it vertex form yet? What do I have to do? No, we don't want to divide by 2. Vertex form, all we need is y by itself again. So I have to take this and move it back to the other side. So we have 2 times x minus 3 squared, what? Minus 2 equals y. Now, what's my vertex? 3, negative 2. It's the opposite inside the parentheses, so it's a positive 3. And it's the same outside the parentheses, so negative 2. So my vertex is 3, negative 2. A is 2. Okay? Does this parabola, if I graph it, it's going to open up or down? Up. How do you know? Good, because A is positive. Okay, the second part of this was to find the solutions. Solve. We have our equation right here. We have our function right there. What do I need to do to that to solve? Let y equal 0. Remember, because when you're solving, you're finding where that graph crosses the x-axis. And y is 0 at those points. Okay? So you take the same equation that we just found, and you just make y equal to 0. And solve for x. And this is what we did in section 5.3. So if I'm trying to get x by itself, What's the first thing I do? Good. Add 2. Get rid of that 2. So we'll have 2 times x minus 3 squared equals positive 2. Right? What do I get rid of next? The 2 on the outside, right? How do I do that? Very good. Divide by 2. So now I'm left with just x minus 3 squared equals 1. What now? Very good. Square root both sides. Don't forget the plus or minus. So we have x minus 3 equals plus or minus. Square root of 1 is just 1. Does everyone recognize at this point that I have 2 separate equations? There are 2 separate equations right now. Okay? Some people were getting confused by me moving this over. If I move this over, it would be 3 plus or minus 1. Some people were getting confused with that. So if you were getting confused with having the plus and minus in between the 2 terms, then separate it into 2 equations right now. This is x minus 3 equals positive 1, and x minus 3 equals negative 1. Okay? That'll give you your 2 solutions. So in both cases, you're going to add 3 to both sides. So x equals 4. That's our first solution. And x equals 2. That's our second solution. With us finding the vertex and the 2 solutions, that tells us a lot of information. If I had to graph, which you don't have to graph in tonight's homework, but if I had to graph this, if the vertex is at 3, negative 2, so 1, 2, 3, negative 2, and I know that my 2 solutions are 2 and 4, those are points on the x-axis. So 2 and 4, I can pretty accurately draw my parabola. Those are 3 solid points on that graph. Okay? Okay, so let's review what we did and how it was different. So, we had something multiplied to x squared. The first step doesn't change. Move your constant over. Once we moved our constant over, I had to get rid of that thing in front of the x squared by factoring it out. That is what you'll do every time. Factor it out. Once you factor it out, you're going to complete the square inside the parentheses. So you'll put plus blank, and then on the other side, that doesn't change. Take half of b and square it, add it there. So before you add it to the other side, multiply it by what you factored out. Write your binomial squared, move things back over, and name the vertex. Okay? Let's try one. I'm going to tell you you're going to have to combine those like terms before you can do anything else. Okay, so let me give you a little jump start. What are my like terms I need to combine? 3x and negative 3x, right? One of them you have to move over to the other side. Which one am I going to move? The positive 3x. This is the one that's going to have to come over here, and it'll become negative 3x, right? So that'll go away from right there. Now, do you want to move the 9 over? No. Why? Because you're just going to have to move it back again. So, originally I said you want y by itself. Well, technically you do. But the first step is to take your constant and put it over there with the y. Well, it's already there. So there's no sense in moving it over here just to move it right back. Okay? So this now becomes 3x squared minus 6x equals 9 plus y. Now, I had someone in another class, or a couple people actually, they thought that there was something wrong with this. 9 plus y is the same thing as y plus 9. That's okay. Okay? They moved the 9. They tried to switch these two, and then they changed signs. Things only change signs when they flip over the equal sign. Okay? If you move things around on the same side, their signs stay the same. Okay? So don't make that mistake. All right. So we factor out a 3, because you can't have anything in front of x squared. Right now, it doesn't affect the right-hand side. So when we divide both of these terms by 3, 3x squared divided by 3 is just x squared. When I multiply back, it has to get back to this. If I redistribute that, okay? Then 6x divided by 3 is 2x. Now I have to make that a perfect trinomial. So I need my plus blank plus blank. Okay, what goes in the blank on the left? A 1. 2 divided by 2 is 1. 1 squared is 1. What goes in the blank on the right? A 3. You can't add 1 over here because you have to take this and multiply it times what you factored out. So 1 times 3 is 3. Now the rest is normal. So as normal as it gets. So this is 3 times. What's my binomial? X minus 1. X minus 1 equals y plus 12 when we combine 9 and 3. Now to get y by itself, we take this, put it back over there. So you have 3 times x minus 1 squared minus 12 equals y. So my vertex is, very good, 1, negative 12. Okay, the second part was to solve. How do we solve for x? Set y to 0. So 3 times x minus 1 squared minus 12 equals 0. What's first? Add 12. So 3 times x minus 1 squared equals positive 12. Next, divided by 3 on both sides. So that's x minus 1 squared equals 4. Next. Very good. Square root. Don't forget. Plus or minus. So x minus 1 equals plus or minus 2. Next. Right. Add 1, or you could set up your 2 separate equations right now. Okay, I'll set up my 2 separate equations right now. So what's my first equation? X minus 1 equals positive 2, or the other way. And x minus 1 equals negative 2. Add 1 to both sides. X equals 3. Add 1 to both sides, and x equals negative 1. So my 2x intercepts are 3 and negative 1. Okay, so let's take this one and put it in vertex form. So the first thing we need to do is, well, the constant's already moved over for us, so we can leave that where it is. So we have y minus 27 equals. We need x squared by itself, so we're going to factor out a 3. When I divide both of these by 3, this will give me x squared minus 5x. 15 divided by 3 is 5. Now, I need to complete the square. So we have y minus 27 plus blank equals 3 times x squared minus 5x plus blank. So let's figure out what makes this a perfect trinomial. So we take our middle term, which is 5. 5 divided by 2 is 5 halves. When we square that, we get 25 fourths. So we added 25 fourths to that side. Now, if you wanted to, 25 fourths, you could write it as a decimal. 25 fourths as a decimal is 6.25. So if you just don't want to deal with the fractions, you could put plus 6.25 in this place right here. Now, before we add anything to the left, we have to take this value and multiply it by 3. So I'm going to leave everything as fractions. 25 over 4 times 3 is 75 over 4. Now on the left-hand side, we need to combine these two. So we have y minus 33 over 4 equals 3. Now we write our binomial. Well, square root of x squared is x. We use this sign, that's minus. And the square root of 25 over 4, we go back to 5 halves. So the last thing I need to do is I need to take this and put it back on the other side. So I have y equals 3 times x minus 5 halves squared. Now it's minus 33 over 4 on the left, so it's plus 33 over 4 on the right. Now I can easily tell what my vertex is. My vertex is positive 5 halves is my x coordinate, and 33 over 4 is my y coordinate. If you put those as decimals, it would be 2.5 and 8.25. Okay, now we need to solve. When we solve, we let y equal 0. So we have 0 equals 3 times x minus 5 halves squared plus 33 over 4. Now, if you left them as decimals, they'd be decimals instead of fractions. That does not change our process at all. First thing I need to do, move that over there. So now that becomes negative 33 over 4 equals 3 times x minus 5 halves squared. Now, we're going to divide everything by 3. Dividing by 3 is the same thing as multiplying by 1/3. On the right-hand side, we do have x minus 5 halves squared. 33, negative 33 over 4 divided by 3 is negative 11 over 4. Now, I need to get rid of this squared right here. So I take the square root of both sides. That eliminates my squared exponent. So I'm just left with x minus 5 halves. Over here, I'm going to break those apart. So it's the square root of negative 11. So that's the same thing as I times the square root of 11 over the square root of 4, which is 2. Last thing I need to do, move the 5 halves over. Oh, I forgot something. I forgot something very important. I forgot the plus or minus. Can't forget that. So we bring the negative 5 halves over to the other side, and it becomes a positive 5 halves, plus or minus I times the square root of 11 over 2. those are my two solutions. My two solutions are, now you can leave it in condensed like this, or you could write x equals 5/2 plus I times the square root of 11 over 2, and x equals 5/2 minus I times the square root of 11 over 2. Those are your two solutions, two imaginary solutions. Write in vertex form and name the vertex, then solve. So once again, this one's already set up, y equals 4s, so that's great. So all we have to do is step 1, take your constant, move it over there. That gets rid of it right here. Step 2, factor out a -3, because we want a positive x squared left. So when I factor out a -3, that's dividing everything right here by -3. So -3x squared divided by -3 is just x squared. 24x divided by -3 is -8x. Now I need to complete the square in here, so I need a plus blank. But if I add something to the left, I have to add something to the right. So, we take 8 divided by 2, that gives me 4. And then we square it, which is 16. So we add 16 inside the parentheses. But when we add a number to the other side, we have to take that 16 and we have to multiply it by -3. 16 times -3 is -48. Okay, so we add -48 to the right-hand side. So we write our binomial squared on the left, so -3. Still stays on the outside. Square root of x squared is x. Use that sign, it's minus. Square root of 16 is 4. Equals y. Now you have plus 27 plus -48, which is -21. Last thing, take the -21, put it where it belongs, so now we're putting the constant back, equals, plus 21 equals y. That is vertex form. The vertex is +4, that's our x coordinate, +21, that's our y coordinate. Now we need to solve. And when we solve, we simply let y equal 0. We're finding the x-intercepts. So we have our equation that we just wrote. Y is 0. So, first, move 1 over. Now, we have to get rid of this -3, so we divide both sides by -3. So we have x minus 4 squared equals 7. Now we take the square roots, get rid of the squared, and this time don't forget the plus or minus. So we have x minus 4 equals plus or minus the square root of 7. And then move the 4 back over. So x equals +4 plus or minus the square root of 7. So this is my both solutions written in one statement. But if you wanted to write them as two separate solutions, it would be x equals 4 plus the square root of 7 and x equals 4 minus the square root of 7. Here are some practice problems that I'd like you to do on your own. The first part is, for each problem, you have to identify the vertex. Now, number 1 and number 2, they're already in vertex form. I already set those up in vertex form for you. So all you have to do is pick out what the vertex is. Then you have to solve. Find the real solutions. Meaning, when you get down to the part where you have to take the square root of both sides. Now remember, just find the solution. You're going to let y equals 0 and solve for x. When you get to the part where you have to take the square root of both sides, if the other side is a negative number, that means it's going to square root of a negative number is imaginary. I don't need to know the imaginary solutions. So if that happens, and you take the square root of both sides, and you're taking the square root of a negative number, stop there, because you know that the solutions are imaginary, and your answer will be no real solutions. So don't do more work than you need to. If the solutions are going to have I in it, then I don't need to know them. For 3 and 4, you have to put them in vertex form first to be able to tell what the vertex is. Okay? In both of these cases, you have something that you're going to have to factor out. In number 3, you're going to have to factor out a 9 after you move 431 over, and after you move the 7 over. In number 3, first you're going to have to factor out a 9. In number 4, you're going to have to factor out a negative 1. And then you'll have to complete the square inside the parentheses, just like we did in the notes. For number 5 and 6, you have to get y in your constant on one side and move the other stuff over first. Same thing over here. You have y in your constant, you're going to have to move the other stuff over. Then you're going to have to factor out whatever's multiplied to your x squared. So I'd like you to practice these, and we'll go over them tomorrow in class.